Hello everyone and welcome to today's webinar on selecting the best design options for your IoT tracking solution. This webinar is brought to you by Samuele Falcomer, Principal Product Manager for Cellular, Bernd Heidtmann, Principal Product Manager for Positioning, and your moderators, Sabrina Bochin and myself, Mandy Ferreira. On the agenda for today is an overview of the tracking market and its requirements. We will be exploring different product options and how to select the right product for your use case. Lastly, you'll have the opportunity to ask our experts any questions you have at the end. As always, this webinar will be recorded and sent to you automatically. The presentation will be available as a PDF on demand, and feel free to ask questions in the control panel as seen to the right. And if we didn't get a chance to cover your questions, we'll be in touch. Samuele Falcomer is responsible for the next generation of LPWA IoT products based on the u-blox LTE chipset. He has a master's in telecommunication engineering, as well as a master in business and administration. Before joining u-blox in 2013, he gained extensive experience as an RF and antenna engineer. Bernd Heidtmann is responsible for the M10 GNSS technology platform and module series. Bernd worked at Huber & Sonner as a product manager for RF products before joining u-blox. He also formerly worked for Siemens and Nokia in the mobile radio base station industry. And now I will hand you over to Samuele. Thank you.
Thanks, Mandy. Good morning and good afternoon, everyone. I'm really glad to be here with you today. As said, today, during this hour together, we will touch a variety of topics. There will be a session on market requirements. There will be another one with a bit more focus on products and solutions. So what u-blox can make available. And finally, but even more importantly, we want to give you today a bit of a guidance and help you pick the right solution for your products. So let's get started. And we can start with a quick overview of the cellular IoT tracking market. Cellular and not GNSS, because typically when you make an IoT tracker, you want to equip it with some sort of GNSS systems. But when it comes to cellular, you have a variety of solutions. What you see on the right side here is a possible split of the market by technology. So what we expect in a few years from now, this is internal source based on analyst data and combined with internal intelligence. And this graph tells us that by 2025, we expect most of the IoT tracking market being connected via the new LPWA, low power, wide area network technologies. Actually, we expect that more than 50% of it will use the new LTM solution, part of it maybe using a 2G fallback option. The remainder of the market will be split between LTE Cat 1 and narrowband IoT. There's also a point about some regional differences in the air interface support. So take, for example, China, but that is true also of other countries around the world. So if you take China as an example, you have narrowband IoT fully deployed, while LTM on the opposite has not been rolled out by local operators. And as a result of this support, you still see many IoT tracking applications using narrowband IoT as the go-to solution, a go-to technology, even though you may opt for potentially other technologies like Cat1 or like LTM that are more suited for this kind of applications. So with that said, and with this kind of market outlook in mind, today, whenever touching or discussing solutions or products for cellular, we will focus almost primarily and exclusively on the new LTM NB-IoT, so on the new LPWA technologies. So with that said, today again, focus is of course on the IoT tracking market. So with that word, we really want to encompass a variety of applications or subverticals if you prefer. We want to consider the fleet management, the automotive services, asset tracking, and definitely we want to include people and animal tracking. So from our perspective, when we refer to a tracking device, we we consider a generic black box equipped with some sort of connectivity, as we said, cellular LPWA as an example. And in addition to that, you have a GNSS solution. So Bernd, what can we say about GNSS?
Yeah, so many people think about if GNSS is really needed or if they can use also other technologies. So I just want to highlight what is really the key elements why to use GNSS. So first of all, it's established and accepted technology, and this will give you worldwide coverage. Of course, only for outdoor. But for outdoor, this is the best technology you could use. And also compared to other technologies, this one will give you quite high position accuracy. We will come back to this later on. And last point I want to mention here is that it works without having any internet connectivity to compute the position. So it means maybe your device cannot send the data using the cellular network for a moment, but still the GNSS can compute the position and maybe the device stores it to send this out later.
Good, thanks. So moving on, design factors. Of course, there are a variety of design factors, but what we listed here are what we believe are the typical design factors that any IoT maker has to consider. And today, during this webinar, we'll be touching most of them, with the exception of security. Security is a much more complex topic that deserves its own time. And for that reason, at the end of the webinar, we'll give you cross links to other public webinars or resources where we extensively discuss security and how we adopt security in both actually cellular and the GNSS positioning portfolio, and how we can actually help you design a secure IoT tracker in an easier way. So design factors, as I said, there are a variety of requirements. What we have here is a list of the typical ones. Some of them are pretty straight, self-explanatory, like cost, size, and power consumption. Others, like the three on the right side here, require a bit of an explanation. So we can start with the cellular connectivity. Cellular is typically the preferred solution if you have to equip your device with some sort of connectivity. And the reason is that cellular gives you ubiquitous connectivity. And take, for example, the new LPWA technologies like LTM and NB-IoT. Well, they serve brilliantly the IoT tracking use cases. And they are also so-called 5G ready technologies. That means they are paving the way to 5G and will be perfectly functional once 5G is fully deployed by operators. And even more, LTM, for example, but same is true of the NB-IoT, they deliver better performance in terms of power consumption, definitely much better than legacy technologies. And there's a point around coverage, depending on, of course, depending on the regions you want to target with your products and solutions. You should, of course, look at the availability of these new LPWA solutions, and you may want to combine those with a 2G fallback solution. And there's also an important remark about the output power, or if you prefer, the power class supported by your cellular connectivity module. And in the last few years, we've seen many module makers adopting a different strategy and launching products that are kind of limited in the output power. And the traditional kind of legacy LTE power class is 23 dBm. That is the maximum output power that typically a cellular module delivers. And in the last few years, we've seen many launching products limited to 20 dBm, and that is 3 dB less, so means half of the maximum output power. We in u-blox, we decided to strategically launch all our products with the standard LTE power class 23 dBm. And there are some motivations that we listed here. Primarily, we don't want to expose our modules and ultimately your products to possible coverage issues in weak signal conditions. There's also a point about retransmission effects that take place when your device works in this kind of weak signal conditions. To reach the base station, you have to transmit longer, and that is a waste of energy, waste of power consumption. And finally, we don't want to increase the challenge on the antenna design. So for all these reasons, our products are all supporting 23 dBm. And so the takeaway here is that you should really future-proof your IoT tracker using one of our 5G ready solutions, all of them supporting power class 3. So with that said, we can move to the GNSS side.
Yes, okay. Let's talk a little bit about the GNSS. We just heard from Samuele about the 23 dBm output power. And of course, this is nice because you can send out your position, but you should also make sure that you catch your position. And here I want to highlight basically two parameters. One is GNSS availability, and the other one is GNSS accuracy. And if we look at the picture on the left, you see quite dense urban area there. And yeah, if you imagine you have a GNSS receiver somewhere there on the street, it will be a challenge for him because in order to provide the position, the GNSS receiver really needs a good sky visibility to work properly. And of course, GNSS position availability and accuracy can be challenging in this environment. So it means maybe your receiver will not even be able to report any position, which is the meaning of this availability term, or maybe the accuracy, so the size of the error compared to the true position will be quite high. And you usually want quite high accuracy and also very high availability. What measures can we provide here to overcome this challenge? So in the center picture, you see the GNSS receiver using all the well-known GNSS constellations, which is GPS, Galileo, GLONASS, and Beidou. And the so-called multi-GNSS receiver improves the position availability in challenging environments. How can he do this? Yeah, the multi-GNSS receiver will see all the different signals from all these 4 constellations and then can select the best ones to compute the position. And this is especially important, of course, if you are in the situation like indicated before. Now, looking at the right, there I have a little graph with the static position accuracy, and this is the datasheet figure you usually find on GNSS receivers. Of course, for a perfect situation for the datasheet, we always give the best situation for the receiver. And this, of course, is different if you are in real life, like we were discussing just before. But the reception of these 4 concurrent GNSS signals, they will allow you to have a better accuracy than just, for example, using one GNSS only. So at the end, your GNSS receiver will ensure the best availability and accuracy using 4 GNSS concurrent reception.
Good.
And back to you, Samuele. No, the second slide. Sorry.
As you prefer.
I will discuss also about this concurrent operation of the LTE modem and the GNSS receiver. So we see a little picture on the right-hand side. Here you see the LTE modem and the GNSS chip embedded in one what we call combo module, and they have separate antennas and they work fully independently. So many tracking use cases, they require this concurrent operation of the GNSS and the cellular modem. So this really means you have two devices in one housing. They fully work independently, and that's a must if you want real-time information or if you want to continuously track the position of this device. And also this concurrent operation has an impact on power consumption. So if cellular and GNSS work fully independently, then we can avoid interruptions in operation if this is well established or set up in this device. And this at the end avoids wasting power, because maybe you have to transmit the data again because there's some interruption, or maybe the GNSS gets RF interference from the LTE modem and needs to wait even longer to compute the position, which at the end comes out as more power consumption. So the question is really, will your use case benefit from concurrent operation, or it's associated power savings? And this brings us to the first poll, I believe.
The first poll, yep.
All right, thank you. Let's take a look at our first poll question. Which type of IoT tracking applications are you planning to design in the next 3 to 6 months? Please make your choices. We will give you a minute and then we will share the results. Okay, I can see the votes coming in, and I think we can close the poll. All right, we have two kind of almost tied leaders with vehicle tracking, fleet management, and asset tracking at the top at about 43% and 51% respectively. Industrial monitoring and health monitoring tied at 16%. And people, animal, and fitness trackers at 32%. Let's move on to our next poll question. So the next question is, what is your current LTE-M module yearly consumption? Less than 1K, 1K to 20K, or over 20K? All right, I think we can probably close the poll now. Thank you all. So we have less than 1K at 49%, 1K to 20K at 41%, and over 20K at 11%. Thank you all for participating.
Good. So moving on, we can now explore the different options available in the market today. So I'm going to show you 3 examples of typical architectural solutions, and they essentially reflect what module makers made or are making available in their portfolio. And we can start with the historically the first one, and the first one that address the IoT tracking market. This is the so-called standalone solution. In a standalone architectural solution, you have 2 separate systems. You have the cellular in gray and the GNSS positioning part that are placed one close to the other, but these are kept as distinct systems. They may talk each other, they may talk with an external application processor, but the point here is that you have 2 really separate systems. And this architectural solution has been the first one, and definitely is still the one that delivers the highest level of performance, especially for the GNSS. And the other advantage of this solution is on the flexibility that it gives. So as a designer, using this solution, you can combine, take for example, the positioning part, you can combine it with that the reckoning option, RTK, dual band solutions. There are a lot of options that you can make on top of it, you can add on top of it. And there are, of course, some downsides. First one is on integration effort that requires a bit more of effort, and then there is also cost. This solution is definitely not the most cost-effective solution possible. What we have seen in the last few years, we've seen many module makers changing a bit the strategy here in a way to minimize the BOM cost, in a way to make a device a bit smaller. They ended up in a solution that we call system on chip. And by the way, this solution you see in the middle is not something u-blox offers. A system on chip essentially tries to minimize the number of components integrated inside a single piece of hardware, inside a single module. And in this solution, you have many blocks, many chains that are simply shared in between cellular and GNSS. But the key point is that you have a single RF front end that is shared in between cellular and GNSS. So this is really the key of a system on chip solution. And this approach has some pros and some cons, as always. The good advantages of this is that you can come up with a much smaller device. And secondly, you have a cost-effective solution because you are minimizing the BOM count. But the key downsides of these is that essentially, due to the fact you are reusing the same RF front end that is shared between the two systems, you cannot serve the two engines, the two systems at the same time. So you have to assign priorities, and you can either use cellular or use GNSS positioning. And that is a major that is a major problem with many IoT tracking applications or use cases, if you want. Based on that, you cannot serve continuous tracking. You cannot have the device always connected with a network while doing a GNSS activity. You may kind of work it around a bit, but definitely this is not suited for this kind of use cases. And that is the major drawback of this solution. And the other con of a system on chip solution is on the performance of the GNSS, as I will show you later. The first system that gets affected by this kind of integration effort is the GNSS. That is very sensible. And as I will show you later, performance is not even close to what you can get on a standalone or on our solution that I'm showing now. So what we have done in u-blox, recognizing this market trend towards smaller devices and in certain cases, cheaper devices, we opted for a different solution, what we call combo module. So once again, you have a single piece of hardware, a single module, but in this case, we integrated inside two chipsets that are designed, chipped down with their own RF front end, because that is the difference. So yes, we tried to minimize the BOM count. We are still reusing or sharing, if you want, components in between the two systems, cellular and GNSS, but here we kept distinct the two RF chains. And that makes a lot of a difference because, I mean, as you can see here listed on the pros, in this case, we can serve the concurrent use of LTE and GNSS, and that is the key. So in this case, you don't have to accept compromises. You can still use and support all the possible IoT tracking use cases. And on top of that, these architectural solutions helped us maintain or preserve the performance of the GNSS, as I'll show you later. But performance in this case get not affected. And finally, size and cost. Yes, there's definitely an advantage in using a combo over a standalone. So smaller devices and more cost-effective solutions in general. On the downside, you definitely have less options as of today on u-blox combos. If you make a comparison with a standalone, that gives you definitely a bit more flexibility on that side. So with that said, if we want to give ratings to these three solutions, we may propose something like this that is clearly subjective. We try to give a rating depending on the different design requirements that we have briefly seen before. And I think the takeaway here is that, as you can get, we in u-blox tend to consider standalone and combo solutions like equal or equally good in serving the IoT tracking market. It then boils down to your actual preference or specific design requirements. So if you have a specific design requirement on size, definitely you may opt for a combo. Vice versa, if you want to add on top of GNSS, dead reckoning, or dual band options, you may go for a standalone. System-on-chip architectural solutions are definitely behind in terms of many factors here. So that was kind of the big picture, and now we can move the focus from the architectural solutions down to the u-blox offering, and we can start having a look at GNSS. Bernd.
Yes, sure. So what can u-blox offer here is a quite comprehensive range of GNSS chips and modules. And I just highlight 3 examples here. If we start from the left, you see the u-blox M10 chip, and this is 16 square millimeters big chip, 4 by 4 millimeter in a QFN package. You might have in your application right now, you have the u-blox M8 chip maybe present, maybe not, but just for information, so the u-blox M10 is 35% smaller than the u-blox M8, which helps if you have a reduced size or size constraints, let's say. So based on this chip, of course, we offer modules. For example, in the center part, you see the MAX module. It's a very famous form factor, this one, and it really allows easy integration because basically no external components are needed, say, beside the antenna, of course. So that's very easy to integrate. And then if we add also the topic of size, because the MAX is 10 by 10 millimeter big, you can go and, for example, select a system in package. Here I just put the example of the Zoe M8Q. You have a similar functionality than MAX or Neo in the size of only 20 square millimeters. So that's very, very compact in size. And this gives you basically 3 different options. And there are other modules and chips as well. Then the next one is I want to talk to today is the CloudLocate Snapshot positioning service. And this is a new technology supporting cloud-based location. So what is it about? Basically, the major part of the power-hungry calculation of the position is done by a cloud service. And this helps to reduce the power consumption of the GNSS chip or module by up to 90%. So just to look at the, let's say, rule of thumb, you can imagine if there is a receiver, a GNSS receiver doing a cold start, it takes about 30 seconds of time. And this 30 seconds of time, the power consumption is very high because this is what we call acquisition phase. So this is really the time the receiver consumes the most power, much more than in continuous tracking mode. And with this technology, the receiver can be switched on for low as 3 seconds only. So if you compare the 3 seconds to the 30 seconds, this gives you the big factor of this 90% of reduction. And power is one thing. The other thing is you need to send your data still to the cloud, to your service. And here also I want to mention that this protocol we are using here for the cloud connectivity it's quite lightweight. So only a few bytes have to be sent from your device to the CloudLocate service and then back to your enterprise solution. So I think that's a very good option if you're really, really constrained with power consumption.
Good. Thanks, Ben. So on the cellular side, there are a variety of options. Again, we may want to focus a bit today on the new LPWA technologies like LTM and narrowband IoT. So what I'm showing here are two combo modules, so designed according to the criteria we mentioned before. So you have a dual chip design inside. And here I showed a couple of products based on two different families. The SATA R5 10M8S is a combo product integrating two chipsets coming from u-blox design and designed and made by u-blox. We have the u-blox UBX-R5 for the LTE connectivity, and we have the u-blox M8 for positioning. In this case, we have the full ownership of the chipset and module. So this is the best product family where we can deliver best support and guarantee longevity and reliability. On the right side, you see SATA R422 M8. This is another combo. The difference is on the LTE chipset. In this case, we are integrating a third-party non-u-blox LTE chipset. And this product is essentially the brother of this one, with the exception of the 2G fallback. This is intended for applications that demand a 2G fallback option. In both cases, these combos give you integration without compromises. Going back to the topics we've seen before, there's no compromise on the performance of the GNSS, on the concurrent operation of LTE and GNSS, and finally, we support the standard power class 23 dBm. And with that said, if size is relevant for your application, you should definitely look at the Alex R5. That's an exciting product we have very recently announced. This is Alex R5. This is a system in package, so it's even a different technology solution. And thanks to that, we've been able to squeeze massively all the components down to a squared 14 by 14 millimeters form factor. It's 1.5 millimeter high, but the point is that we put everything inside a much smaller form factor, maintaining the same things we mentioned just now. So performance, concurrent operation, and LTE at 23 dBm. We should also talk about power consumption. In this case, you have the market leading value of current consumption in PSM. PSM stands for power saving mode, is one of the peculiar modes of these new LTM and narrowband IoT technologies. And here we have an edge over competition. So as a last slide for this section, I want to give you this kind of overview and kind of comparison among u-blox combo solutions and competitors. Competitors A, B, and C are all, in this case, are all based on SoC, system on chip designs. So I think numbers are pretty straightforward. Maybe it's just worth remarking a few things. Once again, the concurrent operation of LTE and GNSS, that is exclusively supported by our combos. That's inherently based on the architectural solution. We said before, we have an edge on performance. We've been able to preserve performance, and you see the numbers. These are numbers you can get if you test our devices or if you take the datasheet that is public. Sensitivity, accuracy, time to first fix, there we have an edge over competition. We should also pay attention, as Bernd said at the beginning, to the number of satellite systems supported, especially the concurrent satellite system. And in this case, we support 3 systems, while others are limited to 1 or 2. And that makes a lot of a difference if you work in like deep urban canyon kind of applications or scenarios, that makes a lot of a difference in terms of accuracy, sensitivity, or even more on time to first fix. And finally, there's a point about the aiding options. You might be familiar or not, but in all of our combos, we make available Assist Now in all of its forms. Assist Now online, offline, and autonomous. And you can even combine it with a proprietary way of getting a course position based on LTE signaling. This is what we call internally, publicly actually, CellLocate. And I think that's it for this section. We can move on and start the second round of polls.
All right, thank you, Samuele. So let's get the next poll up. Okay, so we'll give you a minute to put in your answers. What is your primary cellular communication technology? Okay, so we see LTE-M is in the lead with 55%, LTE-M and 2G at 18%, Cat1 at 5%, and then other at 23%. Let's move on to the next poll question. How relevant is size in your IoT tracking solution? The Sarah form factor at 26 by 16 millimeters is fine, or I need an Alex form factor at 14 by 14 millimeters. All right, I think we can close the poll. So most of you said, almost 70% said Sarah form factor is fine, and 30% roughly said Alex. Thank you all for participating, and let's move on.
Yeah, thanks. So now we can change a bit the focus and look at use cases. And this section, we want to give you just a few guidelines or design recommendations if you want to help you pick the right product. And for the sake of time, we'll be focusing on just a few use cases, but let's start with this kind of mapping. In this case, we map the different subverticals of the IoT tracking market according to the GNSS performance requirements on one hand, and on the other hand, according to the power constraints that you may have. And what we can say here, essentially, there are some differences, of course, among these subverticals. In general, fleet management applications tend to be less stringent in terms of power requirements, but on the opposite, you may have a variety of use cases, but in general, they tend to be more demanding in terms of accuracy or sensitivity. On the other hand, automotive services, but even more people, animal tracking, asset tracking, in such use cases, the focus is more on power than on the accuracy of the GNSS, typically. So based on this kind of mapping, as you can probably see here, gray stands for standalone, and this light red is combo. We tend to think combo and standalone can serve almost all of these subverticals, with maybe with some observations here, some comments. First of all, whenever you have an application that could be fleet management, but the same is true of automotive, of people and animal tracking, for example, whenever you have a bit more stringent requirements on the GNSS, because maybe you want to equip it with that reckoning solution or something else, definitely standalone has an edge here. So you're better off with that. And combo on the opposite, as you can see with this big rectangle here, a combo is a good all-around solution, so covers pretty much well everything. But it's of course a compromise, and that is a good balance, I think, with power consumption, accuracy, sensitivity, performance in general, and cost. So the key word with combo is versatility and and balance. If you demand a bit more in terms of power consumption, like in asset tracking, you are probably better off with a standalone solution. And finally, if you want to get the best of the best, you can combine either a combo or a standalone with a CloudLocate option to get the best in terms of power consumption. So with this in mind, I want to touch now a couple of use cases. Again, for the sake of time, there's much to be said, but for the sake of time, we can focus on a couple. And this one talks about cyclic tracking, periodic tracking. And you can come to the same results in case of continuous tracking, by the way. So in this case, we are looking at the power consumption spent by a combo or by a standalone solution while doing periodic tracking, continuous cyclic tracking, maintaining cellular disconnected with the network, from the network. And why we decided to show you this one? Well, essentially, this is typically the most challenging use case when it comes to a combo module, because in a combo, you are using many components, so you have to necessarily keep up and running some portions of the system. So it's not that as efficient as a standalone solution in that sense. So we decided to show you the most challenging use case when it comes to make this kind of comparison among solutions. And in red, you see the SAR-5 combo. In black, the Alex R5 combo. And finally, in gray, you see a standalone solution where we combined SATA R5 LTE only with Max M10 for positioning. And you can get the point. I mean, standalone definitely shines in terms of power consumption, has an edge over all the combos out there. But there's also a point around Alex R5. In this case, we've been able to drastically reduce power consumption if you make this comparison with the SATA R5 equivalent product. And once again, you can come to the same similar results if you keep the device connected with the network. In that case, you just have a kind of a penalty by being connected with the network. And you can again arrive to the same conclusion if you move to a continuous tracking. So what is the takeaway in this case? So if you have an application like fleet management, micromobility, but in general, if you have these kind of needs, so real-time tracking, good GNSS performance, you have two options, right? So you have a combo or a standalone. Combo, all in all, delivers excellent performance for the IoT tracking market. If you want a bit more, that could be on power saving, or that could be on other options that reckoning, dual band, RTK. If you want a bit more in accuracy or flexibility, you should opt for a standalone. And my second and last use case here is the occasional tracker. The occasional tracking use case has to be explained a bit, but it's very, very common. Essentially, you want to switch on your device only when strictly needed. So sporadic or occasional tracking means that you have everything typically switched off. Whenever needed, you switch on the machine, you get it connected with the network while serving GNSS to get a fix, to get a position. Once done, you upload your data up to the cloud. And finally, you switch off everything immediately after. So this is the use case, and the energy we show here for combo, standalone, and CloudLocate reflects this use case. That again, it's very, very, very typical. And what can we say? Numbers I think are pretty straightforward. Pay attention to the scale used on the left side here on the energy. I think the point here is that, as you can get, combo and standalone solutions are very, very similar. They tend to be almost exactly the same in terms of power or energy consumption in the case of an occasional tracker. And here is where we have definitely an advantage over competing competing SoC solutions. In an SoC solution, you have to time and multiplex your resources. You have a single front end, and so you have to sequentially use LTE and GNSS. In this specific use case means that you have to first connect with the network, then you need to move priority to the GNSS, serve the positioning part, get the fix, go back to GNSS, go back to LTE, reconnect or whatever, depends, and then transmit your data and then switch off. So as you can get, is a kind of a waste of time. In this case, you are definitely not optimizing the air times or the on time, and that translates into a massive waste of energy or power. In this graph, we also split the energy consumption in between cellular and GNSS for the standalone and CloudLocate, so you can see the contribution given by the two systems. The other important point on CloudLocate is on the energy saving that it gives you. On the GNSS front, that is able to reduce at a half the energy spent by the GNSS system. If you combine it in the big picture of all the other activities that you have to perform on this kind of use case, you can see we've been able to reduce power energy consumption down to 25%. That is impressive, massive. So some takeaways. In the case of an occasional tracker, it could be a wearable, that could be another, whatever kind of IoT tracker that relies on a primary or rechargeable battery. If you want an occasional tracking, definitely you have combos and standalone, but you have to consider power consumption tends to be equal in both cases. Standalone still has an edge if you once again need more flexibility or additional features. And on top of that, if you want to get the best of the best, you can add CloudLocate on top of both combos or standalone solutions. Okay, and that was it. Now we have the last round of polls, right, Sabrina?
Yes, correct. Let's get the next poll question up. All right, how often do you typically request a GNSS position with your primary IoT tracker? We'll give you a minute to respond to that. Okay, I think we can probably close this poll. 51% of you said continuous tracking, and then followed by another about 50% of multiple times per hour and multiple times per day. And then there was only a few, 6% that said multiple times per week, or 14% as based on geofencing events. Let's move on to our last poll question of this webinar. Does your device need to report every time it's positioned to the server or cloud via cellular communication? Yes or no? Okay, I think we can close this poll. Have a little bit of a split audience here. 54% of you said yes, and 46% of you said no, not all positions need to be reported. Thank you all for participating today in the polls.
Yeah, indeed, thanks. So to wrap up, what we've seen together today is a variety of things. So we've seen requirements, we've seen use cases. I think the point is that the tracking market is evolving, is massively growing in terms of volumes, but is also diversifying in terms of use cases. And we have seen it reflected on the results of these polls. So different applications means typically you have divergent, different requirements on cellular, on the GNSS. So the best answer is to give you options, and I think you got the big picture today. In u-blox, we have a variety of products on both cellular and GNSS side, but actually we have a combined roadmap of solutions, products, and services that can help you really pick the right product for your use cases. And I think that leads us to the conclusion, right, Sabrina? So you may want to wrap up here.
Thank you, Samuele. So before we head over to the Q&A session, I just wanted to point you to a few more resources on this topic that we have available. So we have a blog on our website at u-blox.com/blog. And there's 3 posts that are relevant, I think, for the audience today. The first one is "Now is no time to whisper," and it is on the 23 dBm transmission power topic. Second one is on our combo modules, which you can see right there. And the third one is on the u-blox M10 platform. We also have on the website at u-blox.com/white-papers 2 white papers, which you can also find in the handout section for this webinar. So you can download them directly if you're participating today. But one is selecting the right hardware architecture for IoT tracking solutions, and the other one is on low power GPS for tracking applications. Okay, I'd also like to point you to the webinar resources on our website at u-blox.com/webinar. There's a few other ones on products and topics we touched on today. So this first one is cloud positioning, a breakthrough solution to transform your IoT business. This is about the CloudLocate service that we heard a little bit about today. Second one is about the Zero R5 platform, providing many more details about this product. The third one, IoT security as a service. We didn't go deeply into security today, but here we provide an opportunity to look at this topic a little bit more. And then this last one is actually available on YouTube as a video about the u-blox M10, our new GNSS platform. Okay, a couple links here also for if you're interested in contacting our sales team or our technical support portal, feel free to use the links on this page. All right, with this, we are at our Q&A section. So let me take a look at some of the questions here. We've had quite a few coming in, and let's take a couple minutes to respond to those. So there was one question on the performance of LTE-M versus NB-IoT, specifically for moving applications, so at vehicle speed. What about handoff? And is there a dependency of performance on the size of the data? Meaning, does a smaller data communication package, is that more acceptable for handoff, for example?
Yeah, what we see in regions where narrowband IoT is used for IoT tracking applications, we see it used on semi-static kind of applications. That could be animal tracking or could be goods tracking. So semi-static means with speeds less than 50 kilometers per hour. And higher than that, that could be problematic typically. So I don't have the right number, but that's the ballpark.
Okay. Right,
and then it also depends on, just to say, it depends on the network support. There are a couple of different implementations that networks may or may not have, and that makes a difference in terms of the speed you can, the speed limit you may have on while using NB-IoT. So there's also that point to consider.
Okay. Thank you. So we also have a couple questions on features for the M10. One of those is, does the GNSS M10 receiver support decimeter precision with RTK?
No, it does not. So if you want to use RTK, please refer to either u-blox M8, or if you also want to go to decimeter precision in really low decimeter level, you need to refer to u-blox F9, which is the high precision product line.
Okay. I think there's a related question here. Does the M10 line support IMU for high precision location determination inside buildings?
No, inside buildings, for sure not. We still, the GNSS does work outside buildings. And referring to the IMU, Also this one, please refer to u-blox M8 or u-blox M9.
All right, excellent. I think we maybe have time for 2 more questions. So let me take this one. What power savings can my application achieve under concurrent cellular and GNSS operation?
Yeah, that's a very good question.
Worst case, right? That's the worst case.
Yeah, right. That's a bit generic in a sense that, of course, it depends on. I mean, as we have seen before, it really boils down to the actual use cases. So if you make a sporadic use case, that is one thing. If you do cyclic tracking, it's completely different. And in general, I think the key concept is that if you use a combo solution, but that is also true of a combo of a standalone. If you use a combo, you can parallelize as many activities as possible. So you have essentially 2 systems that work kind of independently. While if you use an SoC, you have to sequentially process the other things. So I cannot give you a number. We gave you a couple of numbers based on those specific use cases, but we should definitely look at specific use case to understand what is the actual power consumption, energy consumption. That, by the way, depends also on the network settings when it comes to cellular, and it's really use case dependent. But we have the expertise, as I think you got from what we have seen today together. We have the expertise in house, and our support team can definitely help you on that front.
Yeah, or maybe you can also check the M10 white paper. This gives you some options to save power, hardware options, firmware options. But I think this mode is really the most power hungry mode you are aiming for. Maybe you can go for some power saving options.
Right, and there are, of course, power saving options also on the cellular front. So again, there's a lot of public docs out there, and yeah, we have multiple power saving options on that as well.
Okay, thank you both. So last question, is there a difference in RF interference between combos and standalone solutions?
Well, what we have done designing Alex or Sarah combo products, we paid extra attention in making a good GNSS design. GNSS is what gets affected most, and we have a good expertise in making modules and chipsets and products in general for positioning. So we designed all these objects carefully. You see it reflected in our technical documentation, and you can try by yourself getting samples if you want. So technically it could be, but the short answer is no. We are actually declaring the same kind of, I mean, we're not declaring any kind of performance degradation on that front.
Okay, I think that brings us to the end of today's webinar. Thank you all for joining. Any questions we haven't gotten around, we will reach out to you separately. Thank you, everybody.
Thank you all.
Thank you.
Bye, have a good
Bye-bye.